In this vlog, we will continue the concept of recursion and also will see what is the use of tail recursion. So now in our previous vlog, we have seen the factorial concept and we have made use of recursion here. So now when you try to find out the factorial for 30, so now what you got, the result is like this number is a factorial of our 30. So now let us try to find the factorial of 34 now. You will be getting a 0. So this is what the error we have faced in our previous tutorial as well. So why we have faced this error? So before getting to the error, now let us try to find the factorial of 33 once. So the factorial of 33 is, this is the value, and now we need to know one important thing before proceeding to the error. So what is that is, so this is a range of the integer. So here the output is exactly matching our range here. So when you go beyond this, our integer can't handle the values. So that's the reason we are getting 0 when you are going beyond the value 33 here. So for 33 we have got the factorial value is this particular value we got as a factorial value, and when we are going beyond 33, that is 34, 35, you are getting the value to be 0. So what needs to be done here is you need to replace the integer with big integer. Kotlin provides us this big integer for which you need to import the package java.math. So here once you import this package, then you can use the big integer in your coding. So now this particular number is of type integer here, but we are accepting big integer, so we need to convert it to big integer now. So this normal integer 33, we need to be converting it to big integer in this way. So here in order to convert our integer value 33 to big integer, you need to specify big integer, and inside the brackets you need to specify the double quotes and you need to provide 33 over here. So now our value is being converted to big integer, and you can see our error is no more visible. So and also here you need to return big integer itself, because we need to handle big integer only, so we need to return big integer to handle it. So we get the result in the form of big integer, so you need to return it with a big integer to handle the value. And here when you try to compare it, you need to have big integer of 1 here, or else you can also make use of big integer dot, here you are having some constant values like 1, 0, 10, and you can just make use of 1 here. And now finally here also you need to replace big integer dot 1, and again it's your wish, you can just specify how we specified 33. So in the same way you can specify 1, 0. So there is nothing much difference when you compare them. So now let us try to run the code and see the value. So for 33 we have got the output, and now let's try to go beyond 33. So previously when we tried 34 we got 0, and now you can see we have got the value for 34 even. So we found the factorial for 34. So now let's try for a bigger number, 50. So yes, we got the factorial of 50 as well. So let's try for a big number again for 5000. So we have got the 5000 factorial as well. So now let's go beyond it. So let's try with 50,000. So now we have got an error here. The range of big integer is simply unlimited, so it's based on your system configuration, that is RAM capacity again. So why we got an error again? We are using big integer, but the reason here is you are making the calculations beyond the computational range. So what's happening here is like, so you're making calculations which is going beyond the capacity of your RAM. So here, to make it easier for you to understand, let's make it a simple. So I'm considering the factorial of 5. So whenever you provide 5 here, 5 enters this particular method here, and here 5 into factorial of 5 minus 1, that is 4. So again it will run this method, and here you are keeping 5 in hold. So here you are keeping the computation 5 into 4 in hold, and in the meanwhile you are getting the factorial of 4, and in the same the cycle continues until you reach the 1, and finally you are making the computations. So it's good for the small number. When your number increase, the computation level also increases, and it will go beyond the handle capacity, and it will result in errors. So to handle these particular scenarios, we need to make use of tail recursion. So here this is a concept of tail recursion which we are going to see in this particular tutorial. So here, yes, we have specified tail recursion, and now you need to handle the result. So this particular number, instead of multiplying here, I am going to multiply here into result. So this result also is a parameter which our method will accept, and this is also of type big integer. And so here you need to pass the initial value. So I am going to pass big integer dot 1 here, and also you need to return the result instead of number, and you need to compare it with 0 not 1. So here you are not returning the number, you are returning the result. So here you need to compare it with the 0, and you need to return result. And yes, these are all the changes. Now let's try to run the code and see the factorial of 5 again. So yes, factorial of 5 we got 120, and previously we got an error at 50,000, right? So now let us try to find the factorial of 50,000 again, and it's taking time. And now you got the factorial of 50,000 even. So making use of a tail recursion, we have solved the error which we have got in our previous tutorial, and also in this tutorial also we have got the range error. So this is how we can make use of the tail recursion. So what happened exactly is like, we are making the calculations in every step, and we are making use of the calculation in coming steps. So we are not storing the computation in background and waiting for the next level of computation. So we are not putting any pressure on the RAM either. So in this way we can make use of the tail recursion concept, and you can solve the errors in your real-time applications by removing the stack. So previously we were maintaining a stack, and now we are not making use of any stack. We are just calculating every step, and we are storing the result, and we are making use of the result in our next level of computations. So I think this is very much clear for you, and hope you like this tutorial. And if you have skipped the previous tutorial on recursion, I suggest you to go through the tutorial to have a good understanding on this particular topic. And yes, this is it for this tutorial, and if you like this tutorial, do like, share and subscribe to our channel for more interesting content on Kotlin.